Good morning. This is your lecture on Pascal's triangle and binomial expansion. Now, the whole point of this lesson is for a shortcut. So if we would give you a problem, a binary, two terms, and we take it to a power, you would have to change it to 2x minus 7 times 2x minus 7, and you would have to use FOIL to expand this. So we'd have 4x squared, our outside would be a minus 14x, our inside a minus 14x, and our last term's 49. And we'd end up with this particular problem. Now, the thing is, we would like to be able to do this to any power without having to go through the stack process or the FOIL process. To do that requires us to use Pascal's triangle. Pascal's triangle is a shortcut, and each time we're dealing with a plus b to a power. At the first level, we would take it to the 0 power, that would be 1. If we would have it at the first power, the coefficients would both be 1, and all we're looking at is the coefficients. Here, for our squared one, is 1, 2, 1. Now, when we create this next row, the first and the last one are always 1. There's always one more term than the power. Then, you take these two numbers and add, and that's how this number was created. The next two and add. So in row 4, we have a 1 and a 1 on the end. We add these two to get a 4. We add these two to get a 6. Add these two to get a 4. And I've done it all the way through level 8. And again, we have 9 terms when we expand a plus b to the 8th power. So if we would go back over to our example, and if you were given x plus y to the 3rd power, what you would do is you would write the coefficients from Pascal's triangle, and again, if you go, we're going to 3, we're using those coefficients. So you start out very simple with those. Now, you would take your variable here, and you start it with the power, and you go, each term goes down by 1. The last one would be x to the 0, which is 1, and I'm not going to write it. Then you start at the last one, use your second variable, and then you go basically uphill. And again, the last one here is y to the 0, and it's not here. And then we have plus terms between each one of those particular terms. And now I've expanded x plus 3 to the 3rd power without going through FOIL and stack. Now, this is just the easiest level in which to use this. So now, if I gave you 2a plus, oh, I don't know, 7b, the quantity to the 3rd, I'm going to use this information here to take care of it. So, I'm going to write down and in this particular case, the 2a would be x, and the 7b would be y. So, in place of the x, I'd have a 2a. In place of the y, I would have a 7b. Now, once I get to here, it's not finished. I need to simplify each of the terms so that it's now in standard form. So here I would cube both of these pieces, which would give me 8a cubed. Here I would square this one, which is 9a squared. And then I'm going to take 3 times 9 times 7. And of course I don't have my calculator with me. And then if we go over here, we're going to take the 7b and we're going to square it, which will be 49. So we're going to take 49 times 3 times 3. And again, this was 49 times 3 times 3. And the last thing we'll do is take 7 and cube it. Alright, instead of having to go through doing FOIL and then stack to find this expression, we can use Pascal's triangle, and eventually we will put it on a note card and put it in your calculator so you'll have the actual triangle. You put the coefficients down, you start with an x on the one end, work down in powers, start at the other end, go up with the powers, and then decide what your x and y's are, substitute those in and simplify. So Pascal's triangle, again, is a shortcut way of evaluating things where we have a binomial to a particular power. When I grade this, if you notice, there are 4 terms on this. Each term will represent a check. All right? Now, they also have something called the binomial theorem. And if you look at the binomial theorem, it is using your combination formulas that you had yesterday, where we would use it. To be honest, this equation is very messy. I'm not really going to expect you to use this. I basically will expect you to use the binomial expansion. Now, your first assignment for your homework is number 3 on page 355. And the original problem is a plus b to the 4th power. Now, if you go back to Pascal's triangle, these are my coefficients. These 5 coefficients are what I'm going to use. Then you take the first one, your variable here. You start with the first, the same as the degree here. And then each one of these goes down. At the end, you take your second variable, and now you go up. And here is my final answer. If you notice, the degree of this term is 4, the degree of this term is 4, 3 plus 1. The degree of this one is 4, the degree of this one, plus 3 is 4, and the degree of the last one is 4. This is the type of answer you're going to have. Now, when these quantities become something else, that's when it gets messy. Make sure that if you have a negative, that you watch out. Now, all the terms will be negative. This term, which is to the 1st power, would be a negative, whereby this one, which you'd square the 2nd term, would be a positive, and this one would be a negative. All right. I will have these. You can rerun this, and I will resend it to everyone later today. You'll watch the book video, and then you'll start working on homework. But no groups today. If you have questions, have her replay this video or replay the book video. Good luck.